All right, so the next thing that we've come to is the idea of a tree, next part of networks. In fact, we're actually going to look at what a spanning tree is, and next lesson we're going to look at the idea of a minimum spanning tree. So let's just get straight into this. A tree is a special type of network that does not have any cycles in it. It also needs to be fully connected. So one of the skills we need to be able to do is take a normal looking network and to just cut away some of the edges until we have what is only a spanning tree. So to help us understand this, well, let's start with an example of something that is not a tree. So this is a network. While I've got a couple of dots on here, we're fine. Join it up, we have our network connected now. And as soon as we join this edge, we now have a cycle, a loop, if you want to think of it that way. So this one will be no good because it has loops, cycles. Another example of one that might not be connected would be one where we have one that might not be a tree, is one where we have a point just hanging out by itself. This is not connected. So what do we need to have a tree? Well, we need to have points that are connected. So every point that's here must be connected somehow. If I put another point, it needs to be connected. Depending on which way up we draw all the connections, it may look like a tree with a bunch of roots. It might not. It could just look like a crazy thing with something sticking out the top. But basically, from any one point to another point, there will only be one way to get in between the two of them, which is another way of just saying that there are no cycles. Well, a spanning tree is the treed version of a network. So if I've got my network here, it's got 1, 2, 3, 4, 5 points. We might even call them things A, B, C, D, and E. Well, our spanning tree needs to be this same tree, but if we've got 1, 2, 3, 4, 5 vertices, we only need 4 edges to connect them all together because the first edge will connect 2 ends. And then every edge we add after that will add another one. So we only need 4 edges, but at the moment we've got 1, 2, 3, 4, 5, 6. We need to get rid of some. So we could continue to join them up just in alphabetical order. We could join up A, then B, then we could join in C because it's over there, then we could join in D. There's only one way to connect it. And then when we get to E, we've got a choice. Well, we could go this way, we could go this way, we could go that way. Why not? Let's just go back to the one before it. So that would be one way to do it. Another way to do it, again, we've got A, we've got B, we've got C, we've got D, A, B, C, D, E. We'll just randomly join stuff up. Well, there's a connection. From E, we could, let's go to D. From B, let's go to A. And then, let's go there. Yeah, so that's enough for today. And you guys can have a go at the next exercise.